Precipitation is measured as the vertical depth that would accumulate on a flat level surface if all the precipitation remained where it had fallen. To size water transport and storage systems, quantitative data for rainfall events must be provided. This data can be defined in terms of rainfall depth, intensity, duration, and the frequency. The rainfall depth is the sum of rainfall, which is mentioned as depth of water on the flat surface. Intensity or depth of rainfall per unit time is commonly reported in the units of millimeter per hour. Weather stations utilizing gauges that provide continuous records of rainfall can be used to obtain intensity data. These data are typically reported in either tabular form or graphical form. Duration of a storm is the time from the beginning of rainfall to the point where the mass curve becomes horizontal, indicating no further accumulation of precipitation within a certain time after the rain stops. Or the frequency, it's usually called as return period, for example, once in T years. Rain gauge is an instrument used to measure how much rain has fallen. There are several different types of rain gauges that are grouped by how they operate: recording rain gauge, non-recording rain gauge, and rain intensity gauge. For non-recording gauge, this is a standard 8-inch diameter rain gauge. A smaller metal tube may be located in this larger overflow can. An 8-inch diameter receiver cap may be on top of the overflow can and is used to funnel the rain into the smaller tube until it overflows. The receiver cap has a knife edge to catch rain falling precisely in the surface area of an 8-inch diameter opening. Measurements are made using a special measuring stick with graduations devised to account for the 8-inch receiver cap opening, funneling water into the smaller tube. When the volume of the smaller tube is exceeded, it is dumped into the larger overflow can. In contrast to the non-recording gauge, which requires an observer to manually measure the rain at regular intervals, recording gauges doesn't require constant observation. There are at least 3 types of gauges commonly in use to record depth: weighing gauge, tipping bucket, and float type. Weighing type precipitation gauge consists of a storage bin which is weighted to record the mass. Certain models measure the mass using a pen on a rotating drum or by using a vibrating wire attached to a data logger. The advantages of this type of gauge to tipping buckets is that it doesn't underestimate intense rain and it can measure other forms of precipitation, including rain, hail, and snow. However, these gauges are more expensive and require more maintenance than tipping bucket gauges. The weighing type recording gauge also contains a device to measure the quantity of chemicals contained in the location's atmosphere. This is extremely helpful for scientists studying the effects of greenhouse gases released into the atmosphere and their effects on the levels of the acid rain. The tipping bucket rain gauge consists of a large copper cylinder set into the ground. At the top of the cylinder is a funnel that collects and channels the precipitation. The precipitation falls onto one of 2 small buckets or levers which are balanced in same manner as a scale. After an amount of precipitation equal to 0.2 mm falls, the lever tips and an electrical signal is sent to the recorder. The recorder consists of a pen mounted on an arm attached to a geared wheel that moves once with each signal sent from the collector. When the wheel turns, the pen arm moves either up or down, leaving a trace on the graph and at the same time making a loud click. Each jump of the arm is sometimes referred to as a click in reference to the noise. The tipping bucket rain gauge is not as accurate as the standard rain gauge because the rainfall may stop before the lever has tipped. When the next period of rain begins, it may take no more than 1 or 2 drops to tip the lever. This would then indicate that 0.2 millimeters has fallen when in fact only a minute amount has. The advantage of the tipping bucket rain gauge is that the character of the rain, whether it's light, medium or heavy, may be easily obtained. This is another type of tipping bucket. We call this one hobo data logging rain gauge. The logger itself is built of proven rain gauge tipping bucket combined with a pendant data logger. The tipping bucket rain gauge consists of a funnel that collects rainfall and channels the precipitation into a small seesaw. It's a pair of buckets sitting on the seesaw. Each of the buckets will have rainfall falling into it and it will become unbalanced. When the seesaw becomes unbalanced, it will have a movement, the lever tips. If we have a lot of rainfall, we will see a lot of tips, and each one of the tips we can measure and equal to 0.2 millimeters of rainfall falling into the funnel. In this type of instrument, the rain passes into a float chamber containing a light float. As the level of the water within the chamber rises, the vertical movement of the float is transmitted by a suitable mechanism to the movement of a pen on a chart or a digital transducer. By suitably adjusting the dimensions of the collector orifice, the float and the float chamber, any desired chart scale can be used. There are a variety of factors that can affect rain gauge measurements. The positioning of the gauge is very important in order to reduce errors in collecting data. Buildings, landscaping and trees and even the wind can impact the amount of precipitation reaching the rain detector. Proper placement is critical to ensure the rain sensor readings are an accurate representation of the actual rain measurement rates and amounts that have fallen. The ideal site for a rain gauge is in an open area that is protected from the wind in all directions. Therefore, rain gauges should be sited in an open area away from the external factors mentioned earlier. A good guideline to follow as a minimum distance from these objects is twice their height.